Hello, good day. Welcome back to our class, Chemistry 106. Today, we are going to discuss the solutions to the problems which I gave you in exercise number 2 about temperature and time. And as I discuss these solutions, kindly listen attentively and carefully. Problem number 1. The water boils at 100 degrees centigrade. Express this in terms of degrees Fahrenheit, in Kelvin, and in degrees Rankine. So for letter A, the temperature, which is 100 degrees centigrade, will be converted into degrees Fahrenheit. So you use the formula degrees Fahrenheit equals 9/5 times degrees centigrade plus 273. And so the answer is 212 degrees Fahrenheit. In letter B, we're going to express the temperature in terms of Kelvin. So you use the formula Kelvin equals degrees centigrade plus 273. So 100 degrees centigrade plus 273 equals 373 Kelvin. In letter C, you are going to convert the 100 degrees centigrade to Rankine. So you use the formula degrees Rankine equals degrees Fahrenheit plus 460. And the answer is 672 degrees Rankine. For number 2, sodium metal melts at 98 degrees centigrade and boils at 883 degrees centigrade. We are asked to express the melting point and boiling point of sodium metal in terms of degrees Fahrenheit and Kelvin. So for the melting point of the sodium metal, convert the 98 degrees centigrade to Fahrenheit. So you use the formula degrees Fahrenheit equals 9/5 times degrees centigrade plus 32. And the answer is 208.4 degrees Fahrenheit. While in terms of Kelvin, Kelvin equals degrees centigrade plus 273. So 98 degrees centigrade plus 273 will give us 371 Kelvin. We are also asked to convert the boiling point of the sodium metal, which is 883 degrees centigrade, to Fahrenheit and Kelvin. So in converting it to Fahrenheit, you use again the formula degrees Fahrenheit equals 9/5 times degrees centigrade plus 32. So your answer is 1621.4 degrees Fahrenheit. And in terms of Kelvin, you use the formula K equals degrees centigrade plus 273. And the answer is 1156 Kelvin. Problem number 3. A nurse has observed that the patient's temperature is 102.2 degrees Fahrenheit. What is the centigrade equivalent of this temperature? So we are given here the temperature in terms of Fahrenheit, and we are asked to express it in terms of centigrade. So you use the formula degrees centigrade equals 5/9 times degrees Fahrenheit minus 32. And the answer is 39 degrees centigrade. Let's go to problem number 4. Is there a possibility that the temperature reading of the centigrade scale be equal to the Fahrenheit scale? Prove your answer. The answer is yes. So how are we going to get this temperature reading? Now, you equate the centigrade formula as well as the Fahrenheit formula, and let X be equal to degrees C is equal to degrees F. So, your equation will become 5 over 9 times X minus 32 equals 9 over 5 times X plus 32. And the final answer is negative 40. So, this means that at negative 40, the centigrade scale reading is equal to the Fahrenheit scale reading. Number 5. A chess game started at 10:20 a.m. and ended at 12:30 p.m. How long did the game last? So this means we are asked of the duration of the chess game. Since it started at 10:20 and ended at 12:30, let us get the difference between this time of 12:30 and 10:20. So the time elapsed is 2 hours and 10 minutes. Number 6. It takes 1 hour and 5 minutes for Marian to travel from home to school. If she wants to reach school by 8:30 a.m., what time should she leave her house? Marian should start walking from home at 7:25. Number 7. Allison took 54 minutes to wash the apparatus after performing the experiment. Her classmate Claire took 18 minutes less to wash the same apparatus. How long did it take Allison's classmate to wash the apparatus? Now, if we're going to analyze the problem, Allison's classmate Claire washed the apparatus at a shorter time. So, let us get the difference between Allison's time in washing the apparatus and that of Claire's time in washing the apparatus. So, the answer is, it takes Claire to wash the apparatus for 36 minutes only. Number 8. Michael has to get the cake from the cakes and pastry shop to the wedding hall. The drive will take him 1 hour and 30 minutes. If the cake needs to be there at 4, what time must he leave? So that means, if we're going to analyze the problem, Michael should drive ahead of time. So, Michael should start driving at 2:30 p.m. That would be all for today. This is your teacher, Professor Nesitas Ruiz of Holy Name University.